Morning, not to you guys. So last class we discussed about means we talk about finite automata. So what was a finite automata? From last class definition, what is it? Just in simple terms, what is a finite automata? Anyone? Anyone remember which in page? No, automata is not a language. Automata is a machine. It's an abstract machine that accepts some language. Automata is not a language. Automata is a machine. It's an abstract mathematical model. It recognizes patterns, and with the help of automata, you can tell whether a language is accepted or rejected. Okay, so language is nothing but collection of strings. So with the help of automata, we check whether a particular string is accepted by the machine or not. If the string is accepted, then the language is accepted too. So formal definition of automata was what? It was a 5 tuples. Q, sigma, Q naught, and F. What was Q? Q was your finite set of states. Okay, basically states. Set of states. This is set of input symbols. Q naught is the initial state. And F is the final state. So you can think finite automata as an input tape. If you remember, there will be different symbols here. This is your input tape, and there will be a control unit. Okay. So there can be different language, A, B, anything. So first it will always read from left to right. Okay. First it will read one symbol at a time. Okay. It will read one symbol in the tape, then it will move to the next. Then it will read one symbol, then again it will move to the next. Okay. It's just like how we used to process our array. We just check it symbol by symbol, right? One cell to another cell. Similar thing. Okay. Just that now it is kind of actual model. And when it reads one symbol, it change its states. Okay, there are particular states. Whenever it takes or reads one symbol, it changes its state. Okay, then again from one symbol to that, it will again change to another state. So there will be mainly two states here. Two main states. One is accepted, or there will be a reject state. Okay. So if a language is accepted by the automata, then it will be in the accepted state or it will move to the final state. And if the language is rejected by the final automata, it will not go to the final state. Okay. Okay. So there is 5 pages. There is a transition state. 5 to 2. This is transition function. Okay. Now transition function decides how to move from one state to another. Okay, transition function will depend on the type of the finite automata. As you guys know, there are two types of finite automata. One is deterministic and other is the non-deterministic. Okay, so whole finite automata thing, we can also divide it in broader way. Finite automata, then again there are varieties, like there can be a finite automata with output, and there can be an automata without output. Okay, so we are going to learn about these three things. In without output, there is TFA, there is NFA. NFA means non-deterministic automata, and other one is lambda, means an NFA which will accept the lambda empty string. Okay, in FA with output, there is a Moore machine and there is Maillard machine. Okay. So first we will learn about this, then we will learn about this. Finite automata without deterministic finite automata, non-deterministic automata, alpha NFA, and here with output means if it accepts an input, it will also provide an output. So any machine with the output for finite automata is one is Moore, and one is. So in DFA and NFA there is no output. There is only accept state or the reject state. Okay. So before that, you have to understand, in last class also I mentioned, there are certain transition diagrams. I already mentioned whenever it reads one input symbol, it moves from one state to another state. That means it transits from one state to another. Okay. So transition, with the help of transition diagram, you can represent a finite automata. Okay. So transition. So what is it? It basically a graph which consists of nodes and the paths. Okay, the nodes or the cycles are like state. Okay, it's a directed one. Basically, it's a directed. I hope you guys remember what is a directed graph from your third sem. Yes, no? directed graph. Yes, right. Okay, directed graph is nothing but consists of nodes, and there will be arcs, just that there will be a direction to each node. Okay, so transition is nothing but a diagram or directed graph. So with the help of transition diagram, we design or we construct our final automata. So there are certain symbols. Okay, consist of nodes. Okay, nodes we can also say circles, and these are nothing but your states. Okay, this type of nodes or circles will represent states. Okay, and there will be this one, this arrows will be basically the transition. One state to another. Okay, then there is a starting state, you guys already know. So for starting state, we will represent, for example, Q0 is a state. Okay, or Q1 is a state. If I want to represent Q0, Q0 is already there. So you will always represent a initial state with this and a node with an arrow. This is your initial state. Okay. In some places, you also might see it like bar. Okay, Q0 bar. In some places, they show it, but more generic way is to show it like with a circle and the arrow. This is initial state or the start state. Okay. Then we have final state. Final state we represent, for example, Qn is your final state. We represent it with the help of double circle. Okay, this is your final state. So these two things you need to remember. You have to show the initial state. Initial state we show with a circle and the arrow, and the final state we represent with the help of double circles. Okay. For example, now let's come to the DFA part. We will start DFA. DFA means deterministic final state automata. Okay. Okay. When you draw this diagram, sometimes it is also possible that transition tables are given. Okay, transition table is, what is the transition table? I'll show you when we will start the DFA. Okay, transition table means basically it's a tabular representation of the transition functions. Okay, it has like states and the symbol. Anyway, so what is a DFA? DFA means deterministic. Okay, deterministic FA. That means what? It will read one input symbol at a time. Okay, read one input symbol at a time. Okay, and there is only one path from for one particular input for the current state to the next state. Okay, means it will just read one symbol and it will move to the next state. So if there are two symbols, so for every symbol there will be one step. Okay, only one path for specific input from current current next state. Okay, and it does not accept null nodes. That means no null strings are accepted by the DFA. And it can contain multiple final state. Okay, even though from the name it's like there will be only one final state, but it's not like that. It can have multiple final states. Okay, and DFA you can represent with the help of 5 tuples. You guys already know. Q, input segment, Q naught. It's common for all FA. Now we have to know the transition function. Transition function is different. Now you will know the transition functions. Okay. So transition function for DFA you can represent as Q into sigma Q. Always remember. I hate that. Okay, this is for DFA. Always remember that. So what's the meaning? Basically, it represents Q means a state. So if it is in a current state, it will take one input symbol and it will transit to another state. So Q is a state, sigma is an input symbol, and Q is another state. Okay. So a very simple example I'm giving how we can represent it. Okay, for example, we have Q, set of nodes Q0, Q1, Q. Okay. Then I have input symbols 0 and 1. And I have starting symbol Q0. It's the state, okay. And I have final state Q2. Okay. Now, how I can represent this? Okay. In a very simple way, I can represent it as Q0. It's an initial state. I have already mentioned. So initial state means I'll always represent with a circle and a arrow. Next, you have only two options, two input symbols, 0 or 1. So for example, I'm just taking 1. It's taking symbol 1 and it moved to the next state Q1. Okay. Then suppose I'm taking another symbol 0 and finally it moved to Q2. Okay. Now see, for every state for DFA, both symbols has to be used. Okay. So for Q0, I use only 1. Okay. That means 0 is still left. So I can make a self loop here and put 0 here. Similarly for Q1, I use only 0 and I can just make a self loop here 1. So from Q2, it's a final state, but 0 and 1, nothing is going, right? So I can put a self loop here, 0 and 1. This is just an example. I'll show how we can represent the whole language. Okay. Okay. This is your transition diagram. Okay. This is your transition diagram. This is normal example I'm showing you. Okay, now I'll also show how to generate the transition table. So what is a transition table? It's nothing but a tabular form will be given. Then the present states will be given. So how many states are there? 3. Here you will write present state. Okay. Next column will be for the next state for one input symbol. Okay. For input 0. And next column will be next state for input 1. Okay. So in transition table, columns corresponds to the input symbols and row will represent the states. Okay, always remember that row are states and columns will represent input symbols. Okay, then entire and every whole table will represent basically the starting symbol means transition function. See, your transition function is takes input symbol and the state, and next is the transition another state. So transition table is nothing but the representation of this transition function. Okay, so every entry will tell you the next state. Every entry will represent next state. Okay, rest will be same. Okay, now you have to know how you can generate the transition table from the diagram. Okay, so how many states are there? 3, Q0, Q1 and Q2. Correct. So here, which one is the starting? Q0 is the starting, so you also have to mention that Q0 is the starting symbol. Okay, and Q2 is our final state. You can represent it with a star. Okay. Next, you have to show what is the next step when Q0 accepts the input 0. So from Q0, after reading 0 symbol, it's going to what state? It is going to Q0 itself. So it is Q0. Okay. So from Q0, what is the next state for the input 1? So after reading 1, it is moving to the state Q1. So you will write Q1 here. Okay. So for Q0, for both symbols 0 and 1, you have written the entries. What is the next state? Correct? For Q0, after reading input 0, you reach the Q0 again. Okay. From Q0, after reading the input symbol 1, you reach Q1. Okay. Next, you move to the Q1. Now, from Q1, after reading 0, you move to Q2. Right? So from Q1 again, after reading input symbol 1, it just in the same state, which is Q1. Okay. So from Q0, for both 0 and 1, next state is the Q2 itself. Okay, so that's how you can generate the transition table from the transition diagram. Okay, sometimes it also gives the opposite one, means transition table is given and you have to draw the transition diagram. This is the transition table. Is it clear how you write transition table from the transition diagram? You have to just write the all available states in the first column. Okay, present state. Then you have to check what is the next state for every state for a particular input symbol. So we have only two input symbols, 0 and 1. For each of the symbol, it will move to another state. Correct? So for Q naught, after taking or reading input symbol 0, it comes to Q naught again. So next state is Q naught. Okay. So from Q naught, after reading 1, it moves to the next state Q1. So next state is Q1 here. Okay. For Q1, after reading 1, it moves to Q1, and after reading 0, it moves to Q0. For Q0, for both symbols, it just comes to the same state again. So Q0, Q. Is this part clear? How we can write the transition table from the diagram? Just look at the diagram in the table 1, then this is a DF. So for DFA, all finite automata, nothing but it accepts some strings and tells you whether the language is accepted or rejected. So you can design or construct the FA with the help of transition diagram, which is nothing but a digraph or directed graph with nodes or circles and the arcs. Your nodes will represent the states and the arrows will represent the transition to the next state with the help of the input symbols. Okay. Transition table is basically the whole tabular representation of your transition function. Transition function for DFA is always remember it is for example it is in one state, it will take one input symbol and it will move to the next state. So this is the transition function for DFA. Always have to remember. Simple one. It is one state, it will read one input symbol and move to the next state. So this is tabular representation. So do you get the idea how you can write the table from the diagram? Present state is Q1, explain. Okay. For Q1, again same two symbols, right? 0 and 1. For DFA, you have to make sure all symbols are utilized. So for Q1, when it reads the input symbol, it moves to the next step 2. So for input symbol 0, the next step for Q1 is Q2. Okay. Then when it will read Q1, it moves to the same state itself. So next state for the input symbol 1 is Q1. I have already drawn the diagram. Okay, next class I'll show how you can draw this transition diagram. I'll show that part also. Now I'm just giving you the concept how you can, what is a transition diagram, what is a transition table, how you can draw the table from the diagram, and you supposed to means know how to also draw the diagram from the table. Okay, for example, this table is given. Okay, you don't know about the diagrams and all. Only this table is given and you have to construct the DF. So from here you will know how many states are there, right? Q. So in the table given 3 states, so you simply draw 3 circles. You simply draw 3 circles if the table is given. Q0 is the final state, so you represent with 2 circles. Q0 is the initial state, you represent with this one. Okay. Now you have all the states. Now you have to see for input symbol 0 and 1, then what is the next step. So from the table, you know that when Q0 accepts 0 or reads 0, it comes to the same state again. That means it reads 0 and comes to the same state again, Q0. This is done. Now you know from Q0, when it reads input symbol 1, it moves to Q1. That means from Q0, when it reads 1, it moves to Q1. Okay, so for this part, one entry is done. Now you move to Q1 part. So from Q1, you know that when it reads 0, its next state is Q2. That means from Q1, it's reading 0 and move to Q2 because it's already given in the table. Right? Next, for Q1, when it reads 1, it's again in the same state. That means you have to make a self group. And after reading 1, it will be in the same state. Okay, so this part is already done. So this is already given in the table. You are just drawing the transition diagram from the table. Okay, so next Q2. For Q2, when it reads input symbol 2, it moves to the same state Q2. Then again for 1 also remains in the same state. So you can just give 1 comma here and write it like this. That means for both 0 and 1, it remains in the final state. Now you got the idea how you can do means draw transition table and the diagram in both ways. Suppose diagram is given, you have to write the table, or the table is given, from the table you have to draw the diagram. Both ways possible. टेबल से डायग्राम बनाओ, नहीं तो डायग्राम से टेबल बनाओ. ऑल यू हैव टू नो इज प्रेजेंट स्टेट क्या है एंड नेक्स्ट स्टेप क्या है. टेबल में तो सब कुछ दिया ही रहेगा. So from table it is very easier to draw the diagram, and from diagram also it is very easy to draw the table actually. Table से diagram easy. Yes. Table से diagram draw करना is very easy. सब कुछ दिया ही हुआ है. You just need to follow. X not Q not है. 0 लिया, Q0 पे रहा. Q0 है, इनपुट सिंबल 1 लिया, Q1 पे चला गया. एंड फ्रॉम Q1 0 लिया, Q2 पे चला गया. फिर Q1 से 1 लिया, सेम स्टेट पे रहा. और Q2 फॉर बोथ सिंबल्स Q2 पे रहा. डायग्राम इज टेबल, बट टेबल समझ में नहीं आया. ओके, सो टेबल से डायग्राम समझ में आ गया. सो यहाँ से वो ड्रॉ करने के लिए क्या है, सेम थिंग ना. तुम्हें यू जस्ट नीड टू कीप व्हाट आर द स्टेट्स. प्रेजेंट स्टेट में Q0, Q1, Q2 है. यहाँ पे Q0 फ्रॉम द डायग्राम यू नो इट द इनिशियल स्टेट, यू जस्ट गिव दिस सिंबल. फाइनल स्टेट है Q0 दे स्टार दे दिया. बस अभी देखना है Q0 से 0 लिया. अभी 2 ही इनपुट सिंबल है, तो 2 कॉलम रख दिया, 1 फॉर 0 एंड 1 फॉर 1. ओके, सो Q0 0 लेने से Q0 पे रहा. Q0 1 लेने से Q1 पे रहा. फिर Q1 पे है, Q1 ने 1 लिया तो इसने 1 पे रखा. फिर 0 लिया तो Q0 पे रहा. बेसिकली जो डायग्राम पे है वही टेबल पे है, और जो टेबल पे है वही डायग्राम पे है. Okay, I will end the class now. In next class, we will see the example for DFA. Then it will be more clear for you guys. Okay, now we just need to know what's the concept, how you can draw the diagram from the table, or from the diagram how you can create the table. Okay, okay, to the next class here. So I'll just thank you giving me this extra time. Take 10 minutes. Okay, thank you. See you next class.